Hi friends, welcome back to Edupedia world. In the last lecture we discussed about critical angle and we touched upon the concept of total internal reflection. Today we will focus on total internal reflection. We will see the conditions under which total internal reflection takes place and what are the properties of total internal reflection. Upon understanding the idea of total internal reflection, we will see that this can act as an alternate to plane mirror, that is the simple reflection, phenomena of simple reflection, and we will see an advantage which the total internal reflection has over normal reflection. We will also touch upon an example of total internal reflection, that is mirage. So let us see total internal reflection. We saw in our previous lecture that we can run into three different cases when we are when a ray of light is traveling from a denser medium to a rarer medium. The first case was the normal refraction scenario. The second was at a critical angle when the refracted ray traces the interface of the rarer and the denser medium. And the third case was the scenario where the angle of incidence was more than the critical angle and the ray of light gets reflected from the interface. We discussed the critical angle scenario in details in the last lecture. Today we will focus on total internal reflection. So just to refresh the idea, if the refractive index, rather if the angle of incidence, let's call it I, if I is greater than IC, that is critical angle, we have total internal reflection. Now what is exactly happening in case of total internal reflection? What will be happening is that the laws of reflection will take place. The incident ray, the reflected ray, and the normal lie in the same plane. Okay? The angle of incidence becomes equal to the angle of reflection. So all the laws which are followed by reflection will be followed by total internal reflection too. Therefore, let me just summarize it. Total internal reflection 1, incident ray, reflected ray, and this is our normal lie in same plane, and second is the angle of incidence is equal to angle of reflection, not refraction, reflection. Now let us jot down the conditions for total internal reflection. What are the conditions? The first and foremost, the most important condition is that the light must be traveling from denser to rarer medium. Why so? Because if the light were traveling from a rarer to denser medium, then obviously the refracted ray would have been, refractive angle would have been less than the incident angle, and we would never have reached a condition of critical angle. Hence the question of total internal reflection would have been out of question. So the first and foremost thing is that the light must be traveling from a denser to a rarer medium. And given that the light is traveling from a denser to a rarer medium, the angle of incidence should be greater than the angle of the critical angle, that is this angle, corresponding to which the angle of refraction is 90 degree. So when these two conditions are met, total internal reflection takes place. And when the total internal reflection takes place, then these two things happen. Okay, so this is introduction or the idea behind the total internal reflection. Now what we are seeing here is that total internal reflection is very similar to our normal reflection, which you might have studied in your previous classes. So is there something special about total internal reflection which is not there for reflection via a mirror, which we can actually exploit? When we think about it, there actually is something special about total internal reflection. The fact that total internal reflection is taking place on an interface rather than a mirror leads to the fact that the light is reflected 100%. That is, since the angle is more than the critical angle, there is nowhere for the light to go except for being reflected back. And since reflection has to take place at an angle equal to I, all the ray of light moves in this direction at the angle of reflection. So what we are seeing is, let me use different color. One thing is 100% reflection takes place, right? Now what is the influence, what is the effect of 100% reflection? The effect is that the brightness of the reflected ray is very high. Why so? Because there is no losses. The whole incident ray is being reflected back. Therefore, the brightness of the reflected ray is quite high. And as a result, if we use total internal reflection phenomena instead of a mirror, we get images which are much more brighter, which has zero loss, practically zero loss of energy. Okay, so the idea of total internal reflection is exploited in large distance transmission of data in optic fibers, and exactly because of total internal reflection, the diminishing of the intensity of light is very low. As a result, the light can carry information to very large distances using total internal reflection. So this is a very, very important technological importance which is being provided by total internal reflection. Okay, now total internal reflection is manifested in real life in form of mirage. What is a mirage? Mirage is basically when you see the reflection of a tree or a car, even in the absence of water. What happens is, let me draw a image to illustrate it. Suppose this is my ground and the ground is heated up a lot. So the temperature here is much higher than up here, and higher the temperature, less is the refractive index. Okay, now suppose there is some object here, let's say some tree here, and since this position is denser than this position, refractive index here is more than here, because temperature is higher here. So what will happen, when ray of light is moving from here to here, it is actually going from a denser medium to rarer medium, and the refractive index is continuously changing as we move towards the surface. As a result, the ray of light will keep bending away, and finally what will happen, it will reach a critical angle and we will get a total internal reflection. So when you, as an observer, when you see from here, what you will see is this light, and this light being traced back to here, you will actually see the image, the reversed image of the tree, and it feels as if there is water here. And this feeling, this illusion of water is known as mirage. This is what happens in deserts. You see at a distance the desert sand is very hot. As a result, you see reflection which makes you feel there is water or oasis around, when there actually is no water. And this is one of the practical implications of total internal reflection. Okay, so with this idea, I will close today's lecture. We have seen total internal reflection in today's lecture. We have seen critical angle in details in our previous lecture. The next lecture we'll see some numericals, and we'll apply what we have learned in the previous two lectures. Till then, have a great day. Goodbye.